Okay, so today we're going to look at linear modeling, which is just a fancy way of saying writing equations based on particular situations. And the focus of our equations today are linear equations, which means straight lines. So if you are taking this course, you have passed Algebra 2, which means you are familiar with this equation, y equals mx plus b. So just as a reminder, an equation in this form, m is your slope or rate of change. I'm going to say rate of change. That's most of the context that we'll have for these types of problems. B would be a y-intercept or a starting value. Now I'm using rate of change and starting value because today we're talking about real life situations. We don't really say the y-intercept. We would say, what's the original cost, or what is the cost up front, or something like that contextually. So it's a starting value. You may also find it helpful, and we'll see an example of a problem like this, to remember point slope form. So point slope form looks like this, where you have slope still, and then you have a point or a data point at x1, y1, and m is still your slope. I'll show an example of that type of problem. Sometimes if you're given two data points, the best and fastest way to write an equation is actually going to be to use point slope form. So basically I have a bunch of examples here. We're not probably going to do all of them. I just figured more is better. So let's just start basic. You want to rent a bicycle for $20 plus $2 an hour. So it's $20 up front to get the bike, and then it's $2 per hour after that. Well, this would be a good example of using y equals mx plus b. Y equals our slope or rate of change is we have $2 per hour. So it's $2 per hour plus $20. And what we're saying here is it's y is going to be the total cost and x is going to be how many hours that you bike. That's somewhat implied here. We could say a candle is 6 inches tall and burns at a rate of 1/2 inch per hour. So what's happening here, we're looking at number 3, is the candle is actually shrinking because it's burning and losing 1/2 inch per hour. So similarly here, your rate of change is going to be 1/2 per hour, but now it is going down. So contextually, we are starting with 6 inches and we're subtracting 1/2 inch for every hour. So y here would be the height of the candle, and x would be hours. You can also write this y equals negative 1/2 x plus 6. These are the same thing. I wrote it like this originally just because we're starting at 6 and we are losing 1/2 inch per hour. So to me, it made more sense to say 6 minus 1/2 x. I want to do one example or maybe two examples of when we have two data points. So let's try this one. The cost for 7 dance lessons is $82. The cost for 11 lessons is $122. Write a linear equation, slope-intercept form, to find the total cost C for L lessons. And then we'll follow that up and use that equation to find the cost of just 4 lessons. So what's going on here is you're not given a starting amount. You're given 2 data points. You're given 7 lessons is $82 and 11 lessons is $122. What you want to find is, what does 1 lesson cost? Because if you could find what 1 lesson costs, you could figure out what the starting amount is probably to take the class. So how I would do this is you are essentially going to be using the slope formula. So if you want to convert this to 7 lessons equates to $82 and 11 lessons equates to $122. If you think of these as ordered pairs, to find our rate of change, which is just our slope, we subtract $122 and $82 to figure out that difference. And then that's for 4 lessons, and we're getting a 4 from 11 minus 7. So what we have here is, for an increase of 4 lessons, the cost is going up $40. Remember, this is all in context. You're talking dollars over lessons. So what that means is if it's $40 for 4 lessons, that's just $10 a lesson. So now to write our equation in slope-intercept form, we'd want to figure out what our starting value is. And maybe you can do this in your head because $10 is a nice number to use. But in general, what you can always use is point-slope form. So as a reminder, here's general point-slope form. So we'll plug $10 in for our slope, and then we'll pick one of these 2 points as just our x1 and y1. So I'll do y minus 82 is equal to 10 times x minus 7. Then we'll convert this, put it in slope-intercept form. Y minus 82 is equal to 10x minus 70. We'll add 82 over, and we get y is equal to 10x plus 12. Now, the one thing I did not do here was write the total cost C for L lessons. I'm going to convert y and x into the variables they asked me to use. So the cost is equal to $10 times the number of lessons plus 12. And what that allows us to do now is to do a follow-up and say, okay, let's use our equation to find the cost of 4 lessons. Well, now we can use our equation. C is equal to 10L plus 12. We'll just plug 4 in for L. And we get that the cost is equal to 40 plus 12, or $52. So in general, these are going to be your harder problems, but what you're doing is you're finding what is the rate of change. So for us, we went an increase from 7 lessons to 11 lessons. So that was 4 lessons. And our dollar changed from 82 to 122. It went up $40. So you're thinking through, okay, it costs $40 for 4 extra lessons. That's $10 a lesson. That was our slope, or our rate of change. And then in this problem, I chose to put this into the point slope form to help us figure out what our y-intercept was, which is 12, meaning the upfront cost probably for booking the teacher or taking the class is $12 upfront. So that's how we'll wrap this up with that one. So your assignment is to work through the worksheet. You have some of each type of problem. You have some of these with 2 data points, and you have some where you're given the rate and maybe given a starting amount. So just work through that.